welcome to the 2018 Naturalist Night Series. My name is Sarah Johnson. I represent the Wilderness Workshop today. I do lots of things, but tonight, this Naturalist Night Series, as many of you know, is a 10-week free speaker series that happens here in Carbondale on Wednesday nights at 5:30, and in Aspen on Thursday nights at 7 o'clock. It takes a village to make these things happen. It also takes a village to come out and participate, so thanks for being here. We have a number of generous sponsors, but before we get to the sponsors, this is not just hosted by Wilderness Workshop, it's actually hosted by the Aspen Center for Environmental Studies and the Roaring Fork Audubon. We all work together to bring this about. So we have a tremendous number of sponsors who help make this happen. And if you happen to be if you are an owner of one of these businesses, thank you very, very much. And if you know the owners or frequent any of these businesses, please tell them thank you, because this is free because of all of these great people. Tonight, one of our featured sponsor for tonight is the Connected Concierge, which we are very grateful for. And so tonight, one more announcement before I tell you about tonight. As some of you know, we also offer continuing education credit for teachers, and there's an extra long clipboard on this table over here that if you need credit hours, please make sure you sign that. And if you have any questions about that, ask me later. And next, before I tell you about tonight, next week we have a fantastic speaker coming over from the Front Range named Kevin Corwin, and he will be speaking. The title of his presentation is Colorado's Bluebirds and How You Can Help Them. And I had a delightful conversation with him earlier this week, and I think it'll be a fantastic presentation. So tonight was actually, we orchestrated tonight in response to one of your feedback from last year. Somebody in this crowd actually said, why don't we do a local geology night? And I said, oh, what a great idea. And so we happen to have an expert geologist right here in our community. And so Mr. Garry Zabel, he has a master's degree in geology. He actually has been in the Valley of quite a long time. He started teaching at Colorado Mountain College in 1977 as a professor of geology and math. Soon after coming to the college, he began leading multi-day field trips throughout Colorado and Utah. And I'm just curious, how many people here have taken a class from Garry? How many of you have been on a multi-day field trip? Yeah. In 1996, he began teaching a 12-day field course through Earth's geologic history, visiting Capitol Reef, Bryce, and Zion National Parks, which culminated in a 5-day rim-to-rim backpack in the Grand Canyon National Park. Although he is now retired from full-time teaching, he retired in 2006. He continues to teach geology and conduct geology field trips as a professor emeritus, and some of you might even be signed up for his field trip this semester. So without further ado, we have Garry, we have whiteboards and slideshows, and it's just going to be a fun night. So thank you, Garry, for being here.
Well, thank you.
So that they can hear you.
Can you all hear me?
Yeah. I would use that. It's a really full room.
Yeah, but I don't have three hands.
Okay. Do the best you can. All right.
I'll try. If you can't hear me, wave or something like that. Okay. I'm going to start off with a little disclaimer. And actually, it was published in a paper just last week in the Valley Sun Journal. Soper's Sun Journal. Yeah. If you haven't had a chance to read it, there's some copies here. Will, who's the editor and manager and whatnot, writer, did an excellent job listening to me for a while, for about an hour and a half, and putting together something I don't know if I had a lot to do with it. But anyhow, disclaimer here at the end. If you read the whole thing, it says, now what? You won't learn everything there is about geology from this presentation, or a newspaper article, or remember it if you did. But as Zabel often points out to his classes, if you recognize one formation, and we'll talk about what the heck that is if you've never heard it, you can find yourself in geologic time. Whoa. I say it a little different than that. It came out just as good. If you know one formation, then you know it all. Okay? Because you have a cheat sheet in front of you that has a list of the formations. If you didn't get one, they're still around. Grab one or wave your hand and Sarah will get it. There'll be a test at the end of this, so it's open cheat sheet. If you don't have a cheat sheet, you're out of luck. Okay? So, the last paragraph goes on to say, a quote from me, the study of geology, it brings a whole new perspective to the earth. This is our home. We ought to understand it. So that's it. Any questions? Hopefully this works. Okay. I'm going to try to cover 1.7 billion years of time in the next, however I have, 45 minutes or so. Okay, so some of it's going to go fast, but we got to get through it, okay, somehow. So let's start off. Cover page, Geology of Glenwood Springs. We live in a fantastic place for various reasons. But when I was driving from Glenwood to Carbondale tonight, sometimes we forget to look around. And I was looking around, partial sunset and Mount Sopris, and I was thinking, this is a great place. And not only is it great because of what we can see, mountains and so forth, it's great because of the geology. I mean, we have a whole couple textbooks right here. To start off with, geologists like to map things, like others, and they produce some of the best natural art in the world. The earth does. My sister is an art history professor, retired. She's taken me to some museums, and
They can't all hear you.
this is a great museum.
You're going to have to talk into the mic. Because they
Hi,
can't.
is that better?
Yeah.
It's all right. Okay. What do you see? Bunch of colors, right? What do you think those colors stand for? It could kind of indicate something about elevation, but geologic periods and ages of periods, formations. What? Stratification. What? Stratification. Yeah, there's some in there. Okay, good. Okay. And if you look at the Appalachian Mountains, everybody can see those, right? We know where they are, and then we just look over there and say, whoa, that looks pretty complicated, and it is. It has also a lot of vegetation. It's tough to do geology out there because everything's covered up with vegetation and soil. So I go to the desert where everything's kind of laid out for us. But yeah, let's go across country and go way over to here. This is a zone that's kind of different from this midsection of the United States. These are the northern and southern Rocky Mountains. Whoop, I'm not used to this. Okay. One thing that I do want to bring out, we're not going to talk a lot about it, but see this oval shape or round expression within all the colors and the formations? That's pretty spectacular. We happen to be located right about in here, Carbondale. Glenwood. This green area, you can barely see. I'm going to blow this up in just a minute. Happens to be the Grand Hogback. We kind of know where that is, right? Good? Okay. To the west of the Hogback, into this bullseye, we're in the next geomorphic province. Geomorphic, geology, morph means shape sometimes. Okay. This is the, you've all been there, Moab, Needles, Colorado Plateau. Not much of it's in Colorado, but that's okay. The Colorado River goes through it, so that's even better. Okay. Now we're going to get there, but that's another topic to go to the Grand Canyon and all that. But we'll kind of do it as we go. Whoop, sorry. The next slide shows kind of a blow up of the Colorado Plateau. Now we're taking it out of a geologic map. This is a physiographic map, just showing the landforms. Oh my gosh. And we've been there. The geology there is just as outstanding, and it shows up better because this area was uplifted above the surface without tilting and folding and faulting it much. Not anywhere like the Rocky Mountains. Rocky Mountains were formed in a chaotic sense. I mean, folding, faulting, intrusive igneous intrusions, and it's a mess. We can't follow a unit, as I'll show you in a slide in a few minutes, from one area to the next very easily. For example, there's a Leadville limestone around here, maybe, you know. Leadville limestone is behind Hotel Colorado. It was named for rocks over on Leadville, but you can't walk from Leadville to Glenwood all on the Leadville limestone because there's this mountain there. I was going to say stupid, but it's not stupid. I'm sorry. Okay? And you have to go over the mountains to get from one area of the Leadville limestone to the other. Okay? Because of the Rocky Mountains. I mean, it's a mess. Beautiful mess. But it's a mess. Okay? So, let's blow this map up that we saw earlier. This is obviously Colorado. The next one, I guess it's obvious, I'm sorry. Next one shows Colorado and the area that we're in, that we're going to talk most about, and that is in the square here. This green outcropping, map symbol there, corresponds to the hogback. It's all the same rock, it's all the same age. In fact, colors on here correspond to certain age groups. And we'll kind of talk about that later, maybe, if we have time. Okay? So Colorado Plateau, over here, Rocky Mountains, and then Front Range, right here. Okay, so you all, if you happen to be living in this area, are kind of on the edge geologically. If you're in Newcastle, you really have to be careful because you are right on the edge. You don't know where you are. Mountains, plateau. Whoa. If we blow it up a little bit more, this just goes from Glenwood Canyon way up there and all the way to Aspen. This is essentially our route that we're going to take starting about now. We're going to start in Glenwood Canyon because Glenwood Canyon represents the oldest rock units. And we're going to go up and go through a major geologic sequence of rocks exposed in Colorado. We're going to end up, however, in the same age rocks at the end, just to settle down again, something like that. Now, I don't want to hold this up here too long, but the geologic timescale is very important for geologists because we like to talk about rocks. And especially when we're driving around looking at stuff in the CMC van, Colorado Mountain College van, we need to know where we are. And one of the first things I require my students to do is to take a test, geologic timescale test. And if they don't pass it the first time, we go on, if we're going west, to Grand Junction. If you don't pass the geologic timescale by Grand Junction, you're out, okay? No, no questions asked. No, I've never kicked anybody out, so don't worry about that. But geologic time is probably one of the most difficult things to really get in your mind, really. I mean, we're talking about millions of years, which we can't relate to. I mean, we live how long? If we're lucky. I'm sorry. Sorry. If we're lucky, we live, what, 60, 70 years? 80? Okay. And we talk about 100 years or thousands of years or billions of years. I can't grasp it. And geologists call this deep time because it's so deep you can't get there. Now, ironically, I think I understand $1 billion better than a billion years. Can almost feel it. Not really, but okay. So geologically, I think it's best to start at the bottom because that's kind of the foundation. I mean, the Precambrian age rocks are the deep crustal rocks. They are exposed in various places, like the Canadian Shield, at the base of canyons in Colorado, base of the Grand Canyon, and that is because erosion cuts down into the crust of the earth. Into it, not through it, okay? If we didn't have erosion, we couldn't see wonderful cross-sections like we see in the Glenwood Canyon. It's dangerous to drive through the Glenwood Canyon with a geologist driving. It really is. I tried it. I tried it a bunch of times. But for my geology field trips, I decided I better hire someone who drives because I like to point, sometimes both directions, and talk. And it's a dangerous situation. So, Precambrian rocks deal with anything before the period of Cambrian. Okay, how are we doing? Good. Precambrian goes from 5.1 million years, MA stands for million years, all the way back to the origin of time, well, Earth, okay? Paleozoic is the next section of exposed rocks that we delineate. Paleozoic deals with paleo, ancient. Zoic means life forms, time kind of representing that. And we got a bunch of breakdowns here of further categories called periods. Good? How are we doing? Then we go on to the next section is Mesozoic, middle age, middle time, middle forms of life, between 252 and 66. We got 3 periods there. You've probably heard of them. Jurassic, at least, right? Park. Yeah, that's good. 66 million years into the present is overall called Cenozoic. Now your handout is broken down this way also. It gets a little hairy though. And again, we have a limited time. What I have listed for you are the formations in the Glenwood Springs area from Precambrian time, Precambrian's all the way down here, through Paleozoic time, it's labeled over here, Mesozoic time, and Cenozoic. How are we doing? Good. These formations are exposed. We can see them. We can talk about them. We can hit them with a hammer or whatever. Okay, over here to add to your handout information, because a lot of you, I assume, go to the desert sometimes. The geology is a little different, although very similar in ages, but there are some different formations because Utah's over there and we're over here and things change. Okay? So you may have heard of things like the Green River Formation maybe. What's not here? The Navajo Wingate, Kayenta. We don't have those here. In Junction we have some Wingate. Going on because we got to go. There are 3 different types of rocks. Now, I have an old saying, and this is in here. I didn't exactly say that, but you can't take everything for granted. Okay? Some things are kind of like schist. And metamorphic rocks are called gneiss. We'll see pictures of these in just a little bit. So these guys are not my top students, but it's okay. So let's go to the Grand Canyon. I told you we just barely visited. Let me say something and then you'll pick one out, okay? Good. A geologic formation is a group of rock that's distinct from the rock above it and below it. It's a distinct group of rock. We sometimes say it's a rock unit, okay? And if you look at this wonderful picture taken from the south rim above Plateau Point, you can pick out several formations, I bet. One is sometimes called the bathtub ring. It's a clean bathtub, though. I mean, I would pick this out. You can see it forever when you're standing on the rim or anywhere in the Grand Canyon. It's going to be there if the walls are thick enough, deep enough. It's even something that, as an erosional remnant, sticks out. I mean, that's it. And then, boom, little island in the sky. So formations are distinct for whatever reason. It could be fossils, could be rock type. Fossil would determine something about the age, and blah, blah, blah. This is a very spiritual place for me. I made the mistake of going to the Grand Canyon, and I have to get a fix every year. And luckily, I take some students, and they pay my way. Another outstanding view of the Grand Canyon from South Rim to the North Rim. This is the Bright Angel Canyon Creek area. This is the North Rim. The lodge is right about there. This is Phantom Ranch, just to give you an idea if you've been there or know something about it. Well, let's come back to Earth. Well, closer to us, I mean. This is the Glenwood Canyon. Whoa. Where did the horizontal nature go? I mean, you look at this, and you go, hey, this is cool. This is easy. Precambrian on the bottom, cliff, I don't know, we don't have to know the names, Tapete sandstone. We got a bunch of slopes, cliffs, all the way up to the top. Okay, which brings us through Paleozoic, if you look at your handout. And if we had more time, we could really pick out the names for all those, but we don't have enough time, sorry. Okay, come back next time. Now we go to Glenwood Canyon, we go, whoa, it's a mess. This happens to be the Leadville limestone, which is the same as the Redwall limestone in the Grand Canyon if you've been there. It's another prominent cliff former in the Grand Canyon. And it's reddish in color, even though it's not, but we can't talk about that, okay? It's been stained. This goes essentially from the tunnel down here, Precambrian rock, sedimentary rock of sandstone, shales, and then limestone, and then some other stuff. But it's hard. You can't even follow this around the corner. It happens to show up way, way up here, and that's due to faulting and some folding and so forth. Well, let's go look at it a little closer. This is had no name. Looking at the east end of the tunnel, and we're looking at Precambrian rock down here, and Cambrian, Saguache sandstone up there. Tilted, not like the Grand Canyon. It's been messed up, right? Okay. The rock at the bottom is Precambrian granite. This is some of the best looking granite that I've ever seen. It's really super, and if you've been around Horseshoe Bend, that's where this was taken. Look at the rocks. They're telling you something. They tell a story.
Is that at the water level?
I'm sorry?
Is that the water level?
It's below us,
Below it.
but pretty close. Yeah. Now here's the same kind of picture taken a little bit differently. Precambrian down here. Could you count distinct group of rocks up there? Mm-hmm. Yeah, you can kind of. And if you're good, you came up with something like that. Now there is a fault here. Boom. Because this stuff here, being Leadville, doesn't continue across the stream here. It's way up there. That's where the adventure park is. So something had to happen in here. over a long, long time, 1,500 feet of movement along that fault produced what we have today, along with a lot of erosion. Cool. Formations, they're kind of neat names. Let's go on. And I'm sorry we have to rush through this. Looking east of No Name, we can see into the canyon. And again, we can draw lines between the formations. These are contact lines. They're sloping, blah, 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 faulting, kind of neat. Okay? These are the same formations, or at least rock types, that we see in the Grand Canyon. Different names, a lot of them, most of them, at this age anyhow, but similar. We have the Tepete sandstone in the Grand Canyon. Here we have the Swatch sandstone. No big deal. We just call them a different thing. And that's another class. If we go to Hanging Lake, beautiful cliffs. Can you draw your lines in? Well, we don't have time, so here. Precambrian is different than sedimentary rocks because it's all kind of broken up and looks really old. And it is old, and it is broken up. Even though old sedimentary rock is exposed here, we have some evidence of its origin. Layered rocks, 99.9% of the time, are sedimentary. There are some layers of basalt that you can get confused looking at a distance anyhow without looking at the rock. Okay, and they can be horizontal. Columbia River Gorge, really neat. Horizontal basalt flows, not sedimentary rocks. Normally sedimentary rocks form in horizontal layers. Boom, boom. This is all one formation. One that's the easiest to look at and know its name. Because a characteristic, and next time you drive through Glenwood Canyon with someone else driving, you look for the formation that has light and dark colored bands, right towards the top, especially some other places too. That's the top of the Swatch sandstone. The bottom of the next formation happens to be .0. How are we doing? Okay, we're still in the Glenwood Canyon. Okay. Looking at the north side of the Colorado River, we can do the same thing. Precambrian down here, it's always on the bottom if it's exposed. Then we got the Swatch sandstone, fairly thick. Look at the kind of light lines at the top. It's not the best photograph, especially up close. And then on up. Leadville limestone's way up the top. Are you doing okay? Whew. Okay. It starts getting tough here. Next slide. So, one of the biggest deals that I think of about geology is we're looking back in time. We're looking back on ocean type material. The oceans always came from the west, most always. And because of uplift of continents and downdrop of continents, the oceans tended to migrate onto the west part of the United States, southwest especially, spreading their jewels, limestone, sandstone, shales. Okay, so if the surface goes down, the oceans are going to move in, right? Okay, it's going to move all their sediment also. And so we get a sequence of rocks that indicate where the oceans originated, in a sense, where they have migrated. And if we know enough about the rock, do the rocks talk to us? Yeah, very quietly. And we have to know their language. For example, if we see some Leadville limestone, which in this case is way up here, we know because of what it consists of, both the fossils, rock type, appearance, so forth, that it had to have been deposited on our continental shelves. 300 feet deep water, maybe, where a lot of shell organisms are there, maybe some coral reefs, whatever. material that forms into limestone, calcium carbonate. Forms a mineral calcite, but that's the mineral that makes up limestone. So if we see the Leadville limestone in this area, okay, we know that there was an ocean during that time. And we can date that rock by looking at the fossils. So during Mississippian time, we were underwater when this was happening. Now we can follow the Leadville limestone or any other formation around and get a picture, get an idea where it was deposited. And we call that the environment of deposition. Okay? Could be a desert, could be a stream, blah, blah, blah. Delta. Okay? So what has been produced in the last 10 or 15 years with the technology that we have now, with Photoshops and all, Photoshop, we can draw pictures. They're called paleogeographic maps. Oh, okay. Paleo means old, geography, landforms. Okay, how are we doing? Good. So if you look at this, this is from my geology road log to the Grand Canyon. This is 3 slices of geologic time. From top to bottom, bottom to top, doesn't matter. The bottom one happens to be a paleogeographic map produced by Dr. Ron Blakey from Arizona State University. He's retired now, and he sells these things, so that's a little plug, I guess. I don't know. If we know the red wall limestone or the Leadville, doesn't matter, was formed in water, then right here we can take our little paint gun, what do you call it? In Photoshop and just say, spread in an ocean. Well, here's the picture. Okay, and I'll blow that up just a little bit here. That's what the southwestern part of the United States looked at, had to look like this. And what do we have here? Limey, sand, limestone. Well, sandy limestone too, that's okay. Wow. Where are we? Colorado, right? Okay, this whole area here has a potential of having exposures of Leadville limestone. So, kind of neat. It's there. Going back, we can also do that if we go to Zion, and I've just taken slices here. Zion Formation here, which is called the Navajo Sandstone, is a completely cross-bedded, dune field-like sandstone. We can go study dunes, run over here and look at the rock and say, they have the same sedimentary structure. Therefore, they must have been deposited at the same time, even though no one was around 150 million years ago. Okay? And so we take the same map here and we spray in some sand. And that's kind of neat. So Utah was like the Sierra Desert. If we come up in time, if we go to Bryce Canyon, the Clarion Formation, more recent, 60 to 40 million years old, has been determined to be a lake. So we take the same area and we go put in a lake. Isn't that wonderful? Geology is very very visual. I mean, you're driving around, it's visual. And then you make these maps and they're, whoa, that's kind of neat. The next group of rock, and I have to go through this kind of rapidly, happens to be what's called the Eagle Valley Evaporite, which has on top of it Maroon Formation. The red stuff we see all around here, right? Maroon Formation. The Eagle Valley Evaporite formed by evaporation of seawater. Okay? Some trapped portion of the ocean, was able to evaporate very slowly, and over millions of years it deposited gypsum, which is not exactly like salt, but it's a very soft mineral. It can be eroded very easily by groundwater. It has a lot of neat characteristics. The red stuff is very thick, and it's very plentiful around here. These two formations are the youngest of Paleozoic, if you look on your handout. Okay, how are we doing? Good. Quickly, because we're out, is that this is the paleogeographic map of when the Eagle Valley Evaporite formed. This is a little trapped inland sea. And so this water is somewhat fresh coming in, but it's getting saltier and saltier, gypsumier. Okay? When that completely evaporates, and there's a lot of sediment coming from these mountain ranges here, this is filled in with sediment. They may have a little bit of iron in it that oxidizes, and we have, voila, the Maroon Formation. Geology is not bad, right? So there's a great view of some red rocks called Red Mountain before they built on the Glenwood Meadows area. They shouldn't build on geologic features, you know? Here we have some interesting things I'll just throw in. This is a slump feature. All this stuff came from there. That's kind of neat. Next time you go past South Glenwood, look off to the west, boom. You'll look over there every day from now on, because it's just there. Mount Sopris. Whoa. What's Mount Sopris? Anybody want to guess? What? Well, kind of, yeah. Some of you are thinking volcano, but no. Doesn't matter what some people say. Okay. The rocks tell us what it is. It's a grain size that is granite-like. It's got to be intrusive, meaning that we have a bunch of sedimentary rocks at one time that have formed lithology, anyhow. Then we have a magmatic intrusion. Whoa. Okay. It domes up the sedimentary rock layers through 34 million years of erosion. This is 34 million. Now this is present. We have now this wonderful two-peaked mountain. Wow, that's neat. Most likely, as best we can tell, this never really had any material that volcanically got to the surface. The problem is if it did, it's eroded. The key thing to remember, though, is the stuff we see, the mountains we see, the rocks that we see there, were not extruded. It's the wrong type of texture. Crystalline size is not there. And so we can draw these wonderful lines here and say, whoa, 10,000 feet of sediment was on top of here, sedimentary rock. It's gone now. That's good. On top, if you fly over this, or you've ever been up to the top of Mount Sopris, you look down, especially in the summertime, but even in the wintertime you can do this, I guess. This whole area looks like a glacier, acts like a glacier, is not what we typically think of a glacier. It's not ice, it's rock. Oh, there's ice in it, okay. But this is a rock glacier, studied by University of Colorado and other places. This isn't the only one, but it's really a well-formed one. I mean, these look like regular crevasses, whatever. And it does move. I've been told, but I never heard this, that if you camp down here and near Thompson Lake, you can hear rock falling off that. And luckily I haven't done that because I don't like falling rocks. Okay, how are we doing? Whew. You might have heard of the fact that Carbondale is located within a collapse center. It's called the Carbondale Collapse Center, after Carbondale. And one indication that this is a feature that collapsed is the fact that we have all these red dots on it. And each one of those red dots correspond to some kind of sinkhole, some kind of depression on the surface. which could open to a bigger one below. Okay, and especially if you live in this area here, take this home with you. There are more sinkholes per square foot, meter or whatever, in this region between Mid-Valley Mart and south of Carbondale than anywhere else in Colorado. That could be a problem. Okay. Hire a good engineer. There's another one up here. Now, just because we don't have I keep on saying it a lot of time. Let me go through it really fast, and that is, we have some cores here that haven't changed. So if something has collapsed, we should see some evidence. Okay, we have this wonderful Mount Sopers, which is down here. That's not going anywhere. Okay, we also have right about in here Basalt Mountain. That's kind of steady, but in between we've got Eagle Valley Evaporite. It dissolves out very easily. Okay. Oh, so we have some great examples of Eagle Valley Evaporite doing its thing. This is just down north of here. This is Eagle Valley Evaporite. Maroon Formation is right here, and it's hard to get a good picture. There are all kinds of twisty folds in here. The next time you go in the daytime, look at it. That indicates that this had the properties of being somewhat like a liquid, very slow moving. But when things start to move, surfaces get all contorted and all. Okay, this is by Cattle Creek. It's a gypsum dome. Okay, going up valley just a little ways, Catherine's Store down there. This is the road that goes up to Missouri Heights. There's a sinkhole right there on the side of the valley. If you've never seen it, you probably seen it, but you didn't know what it was. There's a sink right here, and in fact, if you stop here and walk over somewhere,
Mile marker 1.
and it's mile mark 1. Yeah, I got that yesterday. Yeah. Okay, you can look down into it, and I think always, if not always, every time I've been there, you see some water too, right on the edge of the valley, and which is kind of weird, but it indicates that gypsum erodes away, dissolves away, and it's carried to where? A lot of it ends up in the Colorado River, in a hot springs pool. And there are 1,000 tons or so that get washed out of the underground. Well, whoa, what's going to happen to the surface? That's a hell of a cavern. It probably won't develop much of a cavern. It'll just start to subside. Okay? Now, geology sometimes just tells us right like it is. This is Basalt Mountain. Tough to see. These are some formations on the side of it. But on the top here, and if you've seen it during the day, and basalt kind of looking up there, it's very horizontally layered. Basalt, though, not sedimentary. Okay? That's how basalt flows flow. They don't flow steep angles. Okay? They flow on relatively horizontal surfaces. Okay? How are we doing? Good? Okay, here we go. Neat diagrams. Oh, I didn't make these, but we can talk about them. Here's the core, kind of the foothold of Basalt Mountain. Here's Eagle Valley Evaporite and pre-evaporate stuff. This is the original flow, horizontal, right? Good. Through geologic time, and we could know these numbers, but I don't right now. As this goes down, this isn't going anywhere, right? As this goes down by dissolving out that Eagle Valley Evaporite, the surface material, which is very hard, basalt's hard, it's good stuff, it'll start to go down also. It has to. What does that do around the edge? Well, it starts tilting it. Whoa. Okay? What about the final? This is today. Well, yesterday I put it together. So these were horizontal. They're supposed to be. They were, but they're not anymore. So a geologist takes a look at dipping layers or dipping flows of basalt, and they say, whoa, how come it's dipping? The word dip means this downward direction. Well, if you drive up Catherine's store a little bit past that other slide that I showed you showing the sinkhole on the side of the valley, you go around a corner and you go, boom. This is Eagle Valley Evaporite. This is basalt, showing some columnar joining, which is kind of neat. Is this horizontal? No. Should it be? It should be if the solution didn't happen. If the valley hadn't collapsed. And this is on the margin of the valley, and that's way out there. But it fits the pieces into a puzzle. Along with the hot springs. Oh, it's really neat. And this isn't that old a total idea. There's a great book that was published early 2000s called something. Tectonics of the Eagle Valley Evaporite. Call me up and I can get you a sample of it. Isn't that neat? Okay, we'll go up valley and we get into Mesozoic rock units, and there's a few here listed: Entrada Sandstone, Morrison, Dakota, Mancos. A lot of Mancos. Not good stuff for building on, but that's okay, as long as you know that. Let's go on to the last point, last area of interest. Glaciation. Glaciers were present here in Rocky Mountains in the last 2.6 million years. They came and went, came and went. And we can see a lot about the erosional effect, the landforms that develop, and so forth. Now, you may know that Greenland and Canada, Canadian Shield area, consisted of big sheet-like glaciers. Came down from further north. In the mountainous region, we don't have thick sheets, although they can get kind of thick. We have alpine glaciers that hug pre-existing river valleys and widen them and U-shape them. And if we know what to look for, and it's not that bad, we can see the footprint of where the glaciers were. And then we can take out our Photoshop stuff and say glaciers in the Snowmass region, old Snowmass, got down to about here because we have a feature called a moraine. These are U-shaped valleys. There's a Snowmass. It wasn't there, but it's okay. East Snowmass, West Snowmass, the Capitol Peak somewhere in here. Cool. This happens to be right around Aspen Business Center. Aspen Airport Business Center. And if you kind of, right in here, that's the airport. It's kind of hard to see. There's a moraine here, and we're going to see it in just a minute. Okay? Yeah. Now, when glaciers melted, formed some really interesting things down valley from the glaciers. As rivers tend to do what they do, they meander back and forth. If the rivers get maybe more volume, more discharge, they'll erode even faster. Okay? Faster moving water can churn up rock more easily, quicker. And so what I'm attempting to show here is that the river's up here, it meanders back and forth, and it starts cutting in different terraces, different layers or layered-like features that consist of river gravels. These are called river terraces. Do we have those around here? Yeah. Let's go to the beach first. And real quickly, if you've been to a beach, and my wife likes to look for shells, and I look for little geologic features. Okay. So what we have here is a river, little tiny rivulet, whatever you call it, that's going out to the ocean. Okay. And it's cut down in a previously existing flat surface, maybe called a floodplain. And this is kind of like a terrace because it's above where it is now. It had to cut down there. Cool. And then we go over here, and there's another layer here that might be slightly above that because it's got a little cliff there. And then this one is is the top one. And you've seen this over by Paonia in the fall when the river, the Paonia Reservoir goes down, especially by the inlet. You see, oh, neat stuff. Okay. Okay. Do we have that around here? Yep. This is kind of a model that we can draw of the different terraces. The thing that's kind of neat, pick up on here, the top one is the oldest because it started at the top. And it just kind of erodes down here and gets to 2 and 3. And do we have that around here? I keep on saying that. Yeah. This is Lower River Road. This is Highway 82. There's another terrace, flat surface here. There's another one there. There's another one there. Whoa. You've seen them if you've driven back and forth to Aspen. I don't know what you thought. I mean, it's hard.
Nice scenery.
Nice scenery. Yeah. So this is an aerial view I stole off the internet. Neat, huh? Just looking northwest, or west mainly. Low flat area, boom, 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 boom. Boom, and I don't know where this is. Aspen, Starwood? Ah, neat. McLean Flats in here? Yeah. Isn't that neat? Well, we can have, there are names for this. The Starwood Terrace, the WJ Terrace for a ranch, large ranch up there. The Airport Terrace, that's where the airport is, and the Lower Terrace. Now you know the rest of the story. When you drive here next, someone else driving, okay? Look at those and you say, these are called glacial fluvial terraces. I love that. Okay, glacial fluvial terraces, which are terraces that were developed because of glaciers melting, and another word for it is outwash. Pretty high flow from a melting glacier can distribute a lot of stuff down valley. And we see them all the way down to Aspen Glen, a little past that. These are the best. And we can see areas where we have bedrock covered up with glacial fluvial terraces. Okay. Manco shale on top of that. That's where the river bottom was. Whoa. I don't know when, but. Then we go to Capitol Peak area. This is a little schematic showing how glaciers tend to erode things out. U-shaped valleys, hanging valleys. Whoa. See, it's kind of suspended up here. Boom. Horns. Do we have a horn around here? Capitol. The triangular remnants of previously eroded stream high points. And so here we are. Boom. Okay. Mount Daly, Capitol, nice dike here, an igneous intrusion. People around here wonder what is that stripe? Whoa. Okay. My full name is Garrett. They named a peak after me. Not really. How are we doing? Oh, really?
Yeah, we started late.
Okay. What's a what?
What's a dike?
A dike is where hot molten material beneath the surface of the earth intruded and under pressure cracked the rock and formed a vein. And so going back to this diagram here, these are all igneous intrusions like Mount Sopris, but not as symmetrical in a sense. But this is where you see salt and peppery granite type rock. Capitol. Daly, yeah, but this stripe here is very fine grain, much finer grain. Kind of pinkish because it has feldspar in it, if you've heard the word feldspar before. And so this was there underground. This is tough. Geologic time and erosion are really two concepts in geology that are kind of hard. But this was there, had to be there first, way underground. Hot molten material started squeezing in a fracture and probably fractured it even more and squirted in there and it eventually cooled and crystallized. You might even think this is the prototype of fracking. I like this kind of fracking. Okay. This is overlooking the Aspen Business Center, looking towards Buttermilk and what do you call it? Highlands. Airport's over here. And I don't know if you've paid much attention to this as you're driving up and down 82, but just to the east of the Aspen Business Center, there's this hump in the middle of, more or less, in the middle of the valley. And you go around the thing and you can see other places that shows the sediment size. And then if you really look around, you can see kind of a hump over here. Not the best photograph, but there's actually a hump here, kind of goes up and it becomes horizontal where the road is, and then there's another little hump here. And it's all made of coarse-grained sediment that's somewhat angular. It's another picture I stole off the internet. I think that's legal. This shows the airport. The last picture was taken from here, down at this hump. 3 dimensions, not the best in this photograph, but it's the best I could find. Here's that hump. It was eroded in this area, but it was there. It kind of attaches to the north side of the Roaring Fork River. Here's the lateral portion of these humps. There's 2 of them, right? Okay, how we doing? Okay.
Deer Hill, terminal marine?
Is what?
Terminal marine?
Yeah, there's features called moraines that are composed of till. Till is sediment that's very poorly sorted. Means it has coarse stuff and fine stuff. Till is angular. Means it didn't roll down a river, but it could be trapped in ice and scrape down the valley. Where the glacier ends, and in this case it happens to be coming this way, it'll push up like a bulldozer a bunch of sediment. Okay? Anything in the front will be here, and we could call that an end moraine first. Anything that, because glaciers got even further down, was pushed to the side. There's one, there's an older one. They're called lateral moraines. Lateral and end. Okay? Sorry, I didn't mean. This happens to be where a glacier came down here, smooshed this pile, lateral moraine, and then it receded. And it receded, I don't know how far, but at least above this feature here, and then it came down again, and it formed an end moraine, which we call a recessional moraine. So it's not a terminal. Terminal means it's the furthest terminus of the glacier. This is even better in a way, because it can tell you a whole story, and that's what we're here for. Rocks can talk. Sediment can talk. How are we doing? Whew.
Is there another moraine on the other side of Aspen?
Yeah. Oh, over here, kind of a medial moraine here.
Yeah.
And then, yeah, we haven't gotten there yet. Another aerial view. I love maps and I love aerial views, but you have to look at them for a little while to figure out what's going on. And I don't know why it looks different over there. Upper left. So here's the airport. Almost, I think it kind of looks better. You can see this hump-like feature right there. And you can see, kind of a trend. That's pretty good lateral moraine. And then there's some other stuff going on here, but these were actually formed by the older glaciers, and there's not as much left over. And that's life for a glacier. Now, if we look into the terminal moraine, or lateral moraine, or recessional moraine, we see this hodgepodge of sizes. We see somewhat rounded, but mainly angular fragments, and that means it had to have been transported and deposited by ice, glaciers. I don't know why I threw that on there again. Oh, yeah. This is a main glacial valley we could say it's synonymous, more or less, in my discussion here, to what's coming down from Independence Pass. That's the biggest valley, biggest U-shaped valley, because that was the main trunk. But Hunter Creek came in, and other creeks you can see up towards Independence Pass or further up. These tributaries are smaller than the main mass here, and therefore they cut a smaller U-shaped valley. And ice doesn't care about a bottom, like water, going over, okay? So what's happens is we end up with these suspended valleys, which we call hanging valleys. And we got a real nice one there in Aspen, Hunter Creek. I mean, this looks like a normal river, U-shaped, kinda. And the water that's coming down Hunter Creek, in Hunter Creek, kind of forms rapids here. But this used to be the bottom of the glacial valley that came down Hunter Creek. And it's probably my favorite. It's easiest to see, and you can see it right in Aspen. Hunter Creek Hanging Valley. Tell that to somebody in a bar, and you. Who knows? Now, this doesn't go quite far enough, but as you go through Aspen, right about in here, you start climbing out of Aspen. And I don't know what that is called, but there's probably a name for it. You climb up, and there's a bunch of houses. Unfortunately, they're built on top of another moraine. And this one happens to be a terminal moraine, because we can connect up valley the lateral moraines and the terminal moraines. And what I do in a class is use my boot or shoe as a glacier and sand and gravel, and I can move my boot down and stop, and you can't see my boot anymore, but on either side of it, the boots are going to have lateral. On the terminus, you can have a terminal. Okay? If we go up further, this is difficult campground area. From here, entrance to difficult campground, the road starts to get steeper. and you have to climb up so that you can go over the next moraine, a terminal moraine, with lateral moraines going up. This is the youngest one close to Aspen. There's one more up by Independence, in the city, the town, the ghost town, whatever. We're not going that far. We go to the Grottos on this virtual field trip. If you park at the Grottos and walk towards the restrooms and past the restrooms, you enter this area that has been sculpted by glaciers. How do we know? Even though this has been exposed for 10,000 years, 12, maybe more, we can still see some indications of the smooth surface by glacier and the rock that's carried with a glacier. These are oftentimes called whalebacks, right? Kind of looks like a whale. Barnacles on them. So go down there, past the bathrooms, you're headed towards Aspen. And this gives you a real pictorial, geologic feel for the direction of movement. It went this way. There's a low place, and there's another whale. But not only that, when we look around more, we see rock types changing. Here we get some metamorphic rocks. This is Precambrian in age. 1.6, 1.7 billion years old. But it has some igneous intrusions, okay, up a crack, that are about 1.4. All Precambrian. So we started in Precambrian at the bottom of the Glenwood Canyon, and we end here. That's kind of, we're not finished yet, almost. Here's a good example of the gneiss granite. There's a rock called gneiss. It's not spelled that way, but gneiss granite. Sorry. Okay. Salt and peppery, probably has more white or pink than black normally. These are found in the intrusions, call them dikes. This is a good example of the gneiss. Gneiss? I'm sorry. Gneiss is a metamorphic rock that formed under high temperature, high pressure, that tended to allow for segregating grains. segregating crystals. The dark stuff, the light stuff, segregates out. But the parent rock of this, the original rock of this, coulda, probably did, look like this. This isn't what was metamorphosed to find that other stuff. This is the intrusion. But if we take a granite, and remember, you can't take everything for granted. I mean, the coloration is not much different. What's different? The banding, right? How come? High pressure and high temperature, and a lot of time, millions of years, hundreds of millions. That's another story. Then, if you go back to the bathroom and go across the bridge, the Roaring Fork River, and up just a little ways, this trail leads to the grottos. Okay, if you've been there, you've seen it. Okay, here, this surface is kind of smooth and grooved. Right? Can you sense it? Yeah. Now we have a problem here because maybe how did they get there? It's kind of a loner. Too big for humans, unless you had a big truck and all. It's not rounded, so what does that mean? Don't go to the answer yet. Okay. So this was glacially transported and dumped right there. We could say that glacier, we shouldn't, took a dump. Okay. As glacier melts, any kind of rock debris that was inside the glacier just settles down to the ground. And it settled there, it looks like to me. There are other erratics around. This is called an erratic. Look in pastures. Owl Creek, yeah. Yeah. Neat stuff. Glaciers right here in our backyard. Grooved surfaces. You put water on this, it really shows up well. Put your hand on there and you're touching a surface that formed, about 10, 12, 14,000 years ago. So we can listen to rocks. They have a language. The language here is striated or grooved surfaces. We look around, what happened? Do rocks talk? Yeah. The grotto is a neat place. The Roaring Fork River has eroded a surface that is indescribable. So, we're going to return to where we started, in a way, to the Grand Canyon. Nowhere have I seen as fantastic sunsets and sunrises. And in September of this year, I'm going to lead another group, if anybody signs up. I have a maximum, it's only 9 students, so let me know. I don't get the permits, though, until May for a September trip, so you can call me before then, but I won't know the dates. Preferably, I want a 10 or 12 day period early in September, because my granddaughter's birthday is early October. Hey, Grand Canyon is a special place, but we live in a special place too. Anyhow, and this is a fantastic photograph that I took off the internet. And according to the wording of this, it said this was taken on full moon night, early-ish in the morning, like 3 o'clock. So really, the canyon was lit up by moonshine, and the fact that it was a timed exposure. And we have some astronomers in this room. We could actually determine the length of the exposure by the length of the arcs. That's kind of neat. So we've taken a wonderful trip, a little fast. If you remember a couple things from this talk, you know everything. with your handout, okay? If you didn't get a handout, there's some more over there.
So we're not done. Oh, I'm breaking things. We
Break
do
it
have
up.
time for a couple questions. The microphone just fell apart. So is that better? Okay. So we do have time for a couple questions. If those of you can, like maybe 2 questions, and if somebody could push the top of the light switches over there, we would have lights. But I have to say, Garry, that's awesome. You know, the Earth is 4.6 billion years old, and you just started from the beginning to the end, and we're an hour. So. Well done. So let's go with, I'm going to have you ask the question. I'll repeat the question for the GrassRoots, and then we'll have Garry answer it. So, Michael.
So is it correct that Basalt Mountain, though made of volcanic rock, is not a volcano?
So the question is, if Basalt Mountain is not, say that again. I got distracted. I'm sorry.
The top of it is volcanic rock, but I understand that it's not a volcano per se.
Basalt is not a volcano, but the top is volcanic. Describe more.
Well, really what we see is all part of the volcanic eruptions that have spread over thousands of years.
The mountain itself is not a volcano. You're just seeing flow on it.
Well, yeah, that's a toughie because we think of, in our mind, of a volcano, they're all cone-shaped of some sort. But Hawaii's not really. Shield, and this is a shield also, but that's usually restricted to ocean stuff, but not necessarily. So there are many, many episodes of flows that in this area was pretty horizontal to begin with, and so we have horizontal layers. So when you're standing in basalt looking at the cliffs towards you can see the layers, and each one of them corresponds to a flow. Just like in the Columbia River Plateau Canyon.
Are those intrusions then, these horizontal flows, does that mean it's intruded?
Each flow would have a conduit for magma, hot molten rock beneath the surface, to come up through the earlier flows and spread out horizontally.
You don't see any particular volcanoes around this area?
Well,
Dotsero?
kind of. Dotsero. Yeah.
Dotsero.
Dotsero. Triangle Peak up here is one.
Okay.
It's entering kind of old Snowmass area. Yeah, it's a young one, 1.4 million years old.
Lady over here has
Yeah.
a question she's going to ask. Go for it in the purple.
Can you talk about the Iron Bridge, all the soil subsidence
Yeah.
and the water issues, sinkholes,
Yeah.
foundations?
Yeah, bad. Between Down Valley Mart, okay, and a little bit south of us, we have the highest number of sinkholes in the state of Colorado. And that sinkholes in the state of Colorado.
Sinkholes.
Yeah, sinkholes where collapsing occurred due to evaporate being, yeah.
All right.
So there was a picture earlier that showed all those red dots.
Yeah.
Each one of those corresponds to a sinkhole.
And that's what leads to the soil subsiding and then
Yeah.
foundations cracking.
And that's much bigger, but yeah. But that's an indication that stuff's going on below it too.
So Garry's going to stick around and answer more questions. It's already almost 7 o'clock, so I'm going to say thank you so much for coming. Before you move, there are a pile of Sopris Sun newspapers over here, and grab them until they're gone, and it has the great summary of history in one page of the Roaring Fork Valley. And just again, thank you to Garry, and thank you to all of you for coming.